to the cybersecurity part for industrial system. And well, I don't know, we can change directly after Jean-Marc presentation, or if you wish, you may have a small break, like 5 minutes. Just tell me, how do you prefer?
A small break is a great idea, I think.
Okay, so let's say 5 minutes break, time that I'm setting up the presentation. So.
Okay. Okay for a break.
Okay, thank you.
Thank you, Jean-Marc, for your talk. And hello to Stéphane. Jean-Marc, if you want to talk to me, I'm sorry, I forgot to reply to your email and to your phone call, so I will do it soon. Okay, about the material.
Yes, yes, yes.
Okay, it's a pleasure to see Stéphane.
Okay.
My first time. Hello, Stéphane.
Thank you, Ahmed. Hello.
Okay, I'll let you for the break and see you soon.
Okay, see you. Okay, so I hope that everyone is back. So if you're okay, we can start now. So again, my name is Stéphane Mocanu. I'm a researcher of the Computer Science Department in Grenoble, Laboratoire d'Informatique de Grenoble. And I'm also with the National Institute of Research in Control System and Computer System in RIA. Control A is the name of my research team, which is a research team working on autonomic control for computing system. And by the way, I'm also involved in the Cybersecurity Institute, which is a big project in cybersecurity in Grenoble. So my talk will be about the cybersecurity of industrial system, and well, it will be a general introduction because in only 1 hour and a half, or less than 1 hour and a half, it's not possible to go into the technical aspects. So we'll keep it quite general, and you'll have a glimpse of what cybersecurity means and what is the cybersecurity of industrial systems. Okay, I will go fast on a very fast review on industrial system. Industrial control system was the main topic of Jean-Marc's presentation, so I won't go into all the details, just I will point out some relevant aspect of industrial control system for the cybersecurity presentation. Well, in the cybersecurity deployment, we focus on the physical plant. So it will be considered the main asset that we have to protect. Well, it's a common misunderstanding that cybersecurity is related to computer and networks. So actually, cybersecurity of industrial control system will focus on the physical system, on the physical plant. Well, of course, in order to secure, to defend the physical plant against cyber attack, we'll have to consider all the devices involved in the control, and starting with the one which are the closer to the physical plant, and those are the intelligence sensor and actuator. So intelligence sensor, because they are able to communicate, and typically they will exchange data with very strong real-time communication constraints, what is called a hard real-time. Well, it was mentioned by Jean-Marc, so I will not insist. So typically you have devices which will communicate among field buses and any other real-time communication system. So at an upper level, you have the controller level. So at this point, you will deploy the automation function and the control function. So the devices involved are the PLC and also are the HMI, the human-machine interface, and maybe some field computer. They will communicate also with some real-time constraint, but which are not as strong as the lowest level. So we are talking mostly about soft real-time. You also have some spatial networks, but not as constrained at the lower physical level. Well, if you are going up in this logical classification of industrial devices, you'll find some piece of software, specialized piece of software, which are the control room, meaning the supervisory control screens, and some databases specialized in the historization and in the storage of industrial data, like SQL, the general one, SQL, but also some very specific databases system like the OPC, which is a highly specialized real-time database. So even if you have to consider time, well, at this level, you are not talking purely about real-time constraints. So the response time is not constrained by some safety or security condition imposed by the physical plant. And finally, at the most higher level, so there are only not real-time remote connection involved, and mostly there will be a database client which will access the process history, or maybe some supervisory client which want to have a remote view of the process of the system. And well, this is completely classical computer system related. So we are using internet technologies, TCP/IP, and everything that people in RUSE has present you in the computer network part. Well, from a point of view of, let's say, of vocabulary of the names used today, so we are usually design the lower level of this classification of this architecture by operational technology. Operational technology just in opposition to the classical IT information technology. So if you want at upper levels, you have only software which correspond to classical IT technologies and devices, but at the lower level you are involved, you are concerned by real-time communication and very specialized devices, and those are the operation technology. So a lot of people will talk about the OT cybersecurity. When you are talking about OT cybersecurity, that means we are concerned about the controllers, intelligence sensor, actuator, and eventually the supervisory control security. And everything else, including the physical plant, will constitute our name cyber physical systems. So they are known under this name because the cyber physical paradigm will include at once the characteristic of the physical device of the physical plant, but also of the controlling plant and all the IT coming around this supervisory and controlling architecture. Now, an important point that one has to understand is that the communication, it's a part of the control system. What I mean, so basically, if you are looking at what is an industrial control system, well, at the lowest level, you'll have what is called the local controller, also the control loop. So the local control loop is the basic block that will build the industrial controlling system. So typically you'll have something like a speed or position control, or maybe a temperature regulation, or maybe a pressure regulation, or whatever. But anyway, it will be a local loop, and typically you have sensor and actuator directly connected to a controller. So there is no communication, not in the sense of computer network, whatever computer network could be, like field bus or TCP/IP, you are not concerned about this. So the local controller, the local control loop is some kind of independent, the basic building block of the control system. So this is the local loop, and well, the local loop will be remotely controlled by higher level controller. This one could be, let's say, a PLC. So a PLC will implement a higher level controlling policy, like a trajectory control. Okay, imagine a robot, you have a central computer, which may be a PLC, that will control the trajectory and will send the set point to the local loops, which will control, let's say, the local position of an actuator. Okay, well, in a complex control system, you don't have only one local loop and only one central controller, but you have many local loops which will interact in order to achieve the global plant control, and they are each one controlled by a higher level controller. And those one will exchange periodically information between them in order to synchronize the various local loops such that they will achieve a very global and long-term control of the plant. So this is what is called a distributed control system and synchronization. Now, at the higher level, of course, you have the control room, meaning the supervisory control and the supervisory screen. And well, the supervisory control will fix the general set point and the general targets. Well, is more or less what Jean-Marc has explained in the previous class. So you'll have to add to those controlling device the safety system. as Jean-Marc has said, and maybe some local human-machine interfaces. And the information flow, if you are looking at this diagram, but you are not interested from the hardware, the pure architectural hardware view, but you are interested, let's say, on the information flow. So the information flow, you have a top-down and a bottom-up information flow. The top-down information flow is the setting point on the target. So the control room will send up global target to the local, to the central controllers, which are instead calculate the set points for the local loops, and the local loops will send periodically reports to the global controllers, which will forward to the control room. So you have a double view, the hardware and let's say a topological view of devices and network, and also an information view, which are these two information flow circulating in the system. Now, what I want to explain with this diagram, with this presentation, is that everything, so including the communication system and including the controller and the supervisory room, is part of the control function, of the global control function. This is very important for the cybersecurity. Why? Because you have to secure everything. You have to secure the control function. You don't have to secure one device. So if the objective of the cybersecurity is to secure a PLC, this is a wrong objective. So the real target is to secure the global control function of the system. And of course, the communication protocol, as you have seen in the previous presentation, they are control oriented. So we are mostly on non-TCP/IP protocols, or maybe on spatial TCP/IP protocols applied to control. So the control elements, they are very strongly interconnected. That's why I told you that you have to secure everything, that the cybersecurity deployment, it's a global approach, it's not a local approach, it's not device oriented, it's the system oriented. And right, the conclusion is that you have to deploy globally the cybersecurity, not device oriented, but system oriented. So the final target is to ensure, once again, the integrity of the physical process. So the physical process is the main asset and has to be taken into account in the cybersecurity deployment. Okay, so that's the global introduction, let's say, and a very, very, very short abstract of the Jean-Marc presentation. And well, now we'll go to cybersecurity and to some very basic definition. Very basic definition, but important, because everything will rely on the good understanding of the elementary definition. The first one is the information system, what an information system is. And well, as you have seen in the previous presentation, in the industrial application, everything is normalized. So there are standards that will define all the entities and all the concepts we have to deal with. And also there are standards that will define what an information system is. So the information system will be the set of all the objects and the resources which are used for the management of the information in an organization. It could be a corporation, could be a company, could be a university, could be a governmental agency. So everything is used to collect, to class, to stock, to storage, to manage, and to dispatch information is into the information system. Okay, so the key word is the information, the basic item we are concerned with is the information, and this one is the main asset for the organization, whatever the organization is. Now, the information system, of course, is set in place in order to optimize the operation of the corporation, of the global organization. So it is intended to facilitate, to make it simple, to help the activity deployment. Now, the main asset is the target of the cybersecurity deployment. In the case of the industrial system, once again, the main asset is the physical process. But into the information system, so you have the main asset, which may be physical process, maybe an information system, maybe a database. If you are, let's say, in a bank, the main assets is the money, is the amount of deposit. If you are in a research agency, the main asset is the knowledge, is the discoveries, the inventions, and the innovation. So the information, it's a very, very, let's say, flow definition of what is the information, what is the main assets to be protected, and it depends on the activity of the institution, of the activity of the organization, and into the information system. So part of the assets to be defended by the cybersecurity deployment are the supporting assets. So the supporting assets, the first one is the organization sites. So actually, the cybersecurity starts with the physical security of the site. So it is completely useless to set up a lot of network protection to impeach cyber attack if you don't have a physical protection of the site. So the threat, the hackers can just come into your site, into your organization, and have direct access to the assets if you don't have a physical access control. So into the supporting assets to be protected are also the people, the operators, the employee of the organization. So they are also one of the objective of the cybersecurity deployment. So cybersecurity is not intended to protect only the information and the computer and the network, but also the people. Of course, there is a hardware, so all the computers or specialized computers in the case of the control system, the communication networks, the software involved, the application could be the control room, could be the embedded software on the devices, or might be a control software used to compute the controlling function. And the organization itself. The organization itself, meaning the structure, the relationship between the services, all the supporting services, the financial service, the human resource service. So everything has to be protected. Actually, the first, I think we'll see that the first step in cybersecurity deployment is to establish the perimeter, to establish the area concerned by the cybersecurity deployment. And well, as I said, everything is normalized. There are standards to specify all those definitions, and this definition of what is the information system, which are the main assets and the supporting assets, comes from one of the main cybersecurity standards, which is known as the ISO IOC 27,000. So ISO is the International Office for Standardizations, is the main standard organization. IOC is the International Electronic Committee, is a standardization organization specialized in electrical engineering and related field, and 27,000 series, including 27,005. This one I'm citing here is the information security standard. So the main standard concerned with the information security. And once again, cybersecurity or the security of the information system is concerned with the security of all those assets, and of course, especially the main asset. Well, we continue with some basic definition. So the security is mainly considered to reduce the system risk. So Jean-Marc has talked about the system risk, and once again, the risk evaluation is the core of the security, whatever the meaning the security is. It could be safety, like in classical industrial engineering. It could be cyber security, like in the cyber risk, like in the cyber security approach. But anyway, the security is intended to reduce the information system risk and to limit the effect of the incident, of the possible incident on the organization activity, on the enterprise activity. Well, usually people are very reluctant when they come back to cybersecurity, because if someone will talk you about cybersecurity, well, the first idea is, oh, I will not have full access to my computer, they will limit my internet access or whatever. Well, actually, it's not true. The security management is not intended to limit your possibilities and to limit your computer use capacity, but on the contrary, it is supposed to provide you a very safe computing environment and to improve the quality of service. Because if you are protected from external cyber threat, so that will increase your experience in using the computing system. And the security, again, cyber security, there is security in cyber security, has to provide an adequate guarantee level of protection for all the users. Right. Well, at the base, let's say in the center of the risk analysis is the notion of vulnerability. So the vulnerability is a weakness of the system. Weakness of the system, it means that, well, you have forget something. You have forget to close one door. Okay, if you are leaving your house and you forget to lock the door, this is a vulnerability. You have an open door. Okay, look at this. Look at the vulnerability in our information system as a door that someone has forgot to lock. Okay, and of course, it's a hole, a hidden door. Usually you don't know about, and it may be used by some bad people to harm your organization. Sorry, and the analogy to a physical vulnerability is completely full in cybersecurity. Well, some common vulnerability in SCADA system, in industrial control system. Now that you know what is a PLC, you have to know that access to the PLC traditionally, historically, is not password protected. So there are many reasons not to protect by a password to access to a PLC. Many reasons that were completely true 30 years ago, which are true vulnerabilities today. But anyway, this is a fact. On most of the PLC, of the actual PLC, you don't need a password and you don't need a credential to have access. So access is completely free. The industrial protocol, you have to know that they don't apply encryption. And again, the main reason to not apply encryption in industrial protocols is the real time. So if you are adding encryption, if you are encrypt the traffic, we'll talk about encryption if we have some time at the end of the presentation. So encryption will add some extra computing charge to your processor. So that's why traditionally network communication for PLC are not encrypted. There is no access control, meaning that a PLC will not check if the control room is the true control room. So if you are setting up a fake control room, if a hacker will want to have a remote access to a PLC, that is perfectly possible. So traditionally, well, on some modern last generation PLC, there is a control, an access control, but traditionally there is none. There is no role-based access control. What means role-based access control? It means that normally on an IT, on a computer system, you can make the difference between an administrator access and an user access. So once you get access to a PLC, you have a full access. So there is no role-based access control, meaning that there is no distinction between a developer that will change the program of the PLC, a maintainer that will only check the logs, or operative that will just apply a manual operation on the PLC. So they all have all the possible right on the industrial device. Well, the protocol are unsecure, so it is related to the encryption. Not only they are not encrypted, but there is no authentication, there is no senator, so there is no integrity check the information, not in the sense of cybersecurity. And well, if you are using some network monitoring tools like Wireshark, which is a freeware software that allows you to see the network traffic, you may notice that you can see all the values exchanged between a client and a PLC. So most of the industrial communication protocol are completely readable, so you can see all the information inside with a network monitor tool. Well, so that's about the vulnerabilities. There are a lot, and that's why we are very concerned with the cybersecurity of industrial system. And well, why the vulnerability are dangerous? Actually, it's not the vulnerability who's dangerous, but the problem is that vulnerability may be used by the threat. Okay, so the second important notion is a threat. The threat, it's a potential incident source. Okay, so the threat by itself, it may sound strange, but the threat by itself is not dangerous. The threat is dangerous if there is a vulnerability that the threat can exploit. Okay, so imagine in real life, a thief is not dangerous unless you forget to lock the door at your house when you leave the house, and then the thief becomes dangerous. The thief is just a possibility of the of an incident. Well, of course, you have the hackers, what is called the hackers, which are the external, the foreign people that want to steal something or want to damage your organization assets. You have some malware. Okay, so there are some blind piece of software that will destroy whatever they encounter. You know that today we are all very concerned with the ransomware, which are a special type of malware that will encrypt your information and then will ask you for some money, will ask you for a ransom to give you the data back. Well, it might be a denial of service. Or denial of service means that some bad guys will get control to a lot of computers or a lot of devices, and they will use it to block the functioning, to block the service on some website or on some servers, and this is called the denial of service. And typically, well, hackers may use whatever devices. They may use computer, they may use security camera, they may use any internet connected device, and well, there are a lot of incidents related to the denial of service. Generally, this will not damage the computer system itself, but will just impeach the operation, the good operation of the system. Well, you may have some internal threat, and typically this is a very dangerous one because someone internal, it is what is called the disgruntled employee. So it's someone that you have just fired. You just fired, and well, he's very unhappy, and before leaving, he will let you an unforgettable souvenir of this incident. So he's someone very dangerous because he's internal to the organization. So he may have some access code, he may have some password, he may have access to some valuable assets. So he may be able to, let's say, to delete some disk drive. He may be also able to maybe to steal some computers, and well, this is one of most feared threat in the IT in cybersecurity. So all those are threats, and once again, the threat is just the possible source incident source, is not the damage by itself. Now, a cyber attack will occur when a threat will encounter a vulnerability. So that's the dangerous situation. So there are no dangers, there are dangerous situations, and the dangerous situation is the moment when the threat will find a vulnerability and will be able to exploit the vulnerability. And there is the last notion, basic notion, which is the notion of intrusion. The intrusion is a successful attack. Well, typically people will talk about attacks, but not about intrusion. So there is a, let's say, a language confusion in the media, especially. So the attack is just an attempt. It is an attempt to harm the system. If the attempt is successful and the system is really harmed, so there is an intrusion. So the intrusion, okay, so it is a successful exploit of a vulnerability that will affect the assets in some way. Yeah? And the cybersecurity process actually will try to reduce the number of vulnerabilities or reduce the possibility to exploit the vulnerabilities that exist on the assets. Well, we know that in real life, to have zero vulnerability of the system, it's impossible. That's why we define or we apply what is called the defense in depth. That means we'll try not to avoid all the vulnerabilities, which is not possible, but we try to reduce the effect, the possible effect of the vulnerabilities and the exploitation of the vulnerabilities. The most important notion to understand is that in cybersecurity, we don't fight the hackers. We don't fight the threat. In cybersecurity, we try to reduce the vulnerabilities of the system. So it is a really defensive only approach. Now, well, is the industry, are the industrial system really at risk? Yes, they are. So there are some statistics. Well, you'll never find 1 month old statistics. So statistics has to be processed, and typically you'll have statistics 4 or 5 years ago. What you see in this diagram, it's a statistic provided by the United States Department of Homeland Security provided. So this will, it is just a statistic on the events that were reported in 2015 in United States. So if you are looking at the number of cyber incidents, so let's say cyber attacks in United States in 2015, you'll notice that 15% had concerned the energy field, and 33% has concerned the critical manufacturing. And this is not covering all the industrial control system fields, because you have also the nuclear field and nuclear material processing concerned, but less than the other one. You have the chemical sector concerned. You have the water transportation, which is also an industrial control field. Transportation system. So you have a lot of incidents that concern the industrial system. And it was confirmed by the statistics. It is confirmed every year. And well, actually, it wasn't the case between 2015 and 2016, but the number of incidents is increasing. Now, maybe you will be attempted to say that 290 or let's say 300 attack is not that much for such a big country as the United States, but actually those are only the reported attacks. So the real number of attacks, it is far more elevated, and the international statistics show that we have an exponential increase of attacks on the industrial system in the last years. Okay. Now, it is important. It is important. Well, actually, it is. So, actually, the industrial system came to the attention of the cybersecurity specialists after 2010. In 2010, there was a famous incident we'll talk about, which is called Stuxnet. So it started with Stuxnet, and Stuxnet, it was an advanced, a very sophisticated threat that, oh, excuse me, that was targeting Iranian nuclear facilities in Natanz. And Stuxnet has physically destroyed part of the plant. And yes, it was a very, very important and very important consequences cyber attack. So it was stopped for several years, the Iranian nuclear development. Then, starting from 2014, there was a series of attacks against the critical system and the industrial system in Europe and United States. So there was a threat called Dragonfly deployed in 2014, and actually it was a data collection threat. It didn't damage the system. It was just intended to test the system, and it was believed to be a preparation attack. And the real attack started the next year with Black Energy, which was targeting the Ukraine power grid, and it was a very serious attack because they black out 200,000 people in Ukraine, and there were 30 electrical substations that were stopped by the attack. So during almost 2 weeks, the Ukrainian electrical network was very, very perturbed. Next year, Ukraine was once again a target of a cyber attack called Destroyer, and that was blackout a quart of the capital of the country during 1 hour. And it continues in 2017 with a very violent cyber attack called Pythia. Pythia was targeted initially against Ukraine, but Pythia was a ransomware, and it propagates through European countries and also to the United States. And more than 2,000 companies were affected, and there was an estimation of several billion euros of financial loss from the main affected companies. And well, I will not list all the attack, but it continues. There was another threat, gray energy, deployed in 2018, and well, the effects were unknown. It is believed that it was just a test, and most probably in the future we'll have more severe attacks against the industrial facilities. 2 years ago, there was another ransomware attack against European companies, especially. So there was an attack against Norsk Hydro. Norsk Hydro is the most important aluminium producer in Europe, and they lost something like 40 million euro in 2 weeks. ASCO, it's a producer for the aeronautical industry. They lost 1 week production, so just a simple ransomware attack put down during 1 week all their production facilities. Pearls is the main producer of safety equipment and safety PLC, not only in Europe. I guess is the main mondial producer of safety PLC, and well, that stopped down during almost 2 months their information system. They didn't communicate about the financial loss. But anyway, what we know is that attacks against industrial system and industrial control system has increased by 2,000% in the last 3 years. So it is a very, very important increase. Now, why are the industrial control system exposed? Why are the industrial system exposed? Well, first of all, there are lots of vulnerabilities. You saw that traditionally industrial devices are not protected, are not cyber protected. They are including only a few, given maybe not at all cybersecurity controls, so they are very vulnerable to attack. But it's more than that, so it is related to the deployment of information technologies in the industrial field. And let's consider an example, a very simple example, which is the electrical distribution, the electrical grid of a country. Okay, so electricity is produced by the generation, which may be a nuclear plant, it may be hydro plant, may be photovoltaic or whatever. And of course, there is a transportation system. The transportation system will transport the electricity, so they are conducting the flow of electrical power until the proximity of the cities, and then you'll go to the distribution network, which is also an electrical grid, which will conduct the power flow up to final consumer. Well, in modern electrical systems, so some of the consumer, most of the consumer probably in the next year are also producers. So it is very common that people are installing photovoltaic panels on the houses, or maybe they will host an small eolian generator, or also some electricity storage like an electrical car. So the consumer is also connected to the generator. It's somehow a consumer and generator at the same time. And this is a very, very, very simplified and extremely simplified view of what an electrical system is. Now, my point is that if you are looking what the information technology connected to the electrical network is, you'll be quite amazed, because, well, there is a controller. Someone will control all the electricity flow transported by the transportation distribution produced by the generator or by the consumer, or consumed by the final user. And well, this dispatcher, the control room, has to get some information for the transport. So there will be an information flow, and there will be a computer network that will connect the dispatcher to the transportation network. So this is a data network. It will also connect it to the generator, because they need to know what's the capacity and what's the actual state of the power plant. It will connect them, of course, with the distribution, and finally with the consumer, because you have to control the consumption. You have to synchronize the production, the small production of the consumer, with the global state of the network. And this is not all, because actually transportation, generation, distribution, and consumer, they have to exchange data. So the generators have to be informed of what's the state of the consumer. Did they produce? Did they consume? They have some storage, and all the information exchanged are intended to help to optimize the global behavior of the network. And they are not the only people exchanging data. So this is only the electrical engineering people, let's say, that exchange data. But nowadays, between the countries, you will change electricities. So you have to change data with the markets. You have to change data also with people issuing some services, because they are not only the national producer and the national electrical network involved, but you have also some private companies which will operate some part of the network, which maybe provide maintenance of part of the system or whatever. So all those people will change data, which all the entity will change the data with transport, with distribution, with the consumer and the generator, and also the services. Now, if you are getting the full view of this system, you may, it's somehow anecdotal, you can say that an electrical network is actually a data network, which, by the way, is also transporting electricity. So that's why industrial systems today are very vulnerable to cyber attack, because practically most industrial systems will have more data flow than production flow. So Industry 4.0 actually is not production centered, it is data centered. The idea is not to produce a lot of goods, is to optimally produce the best goods you can produce. Everything is about money and optimization, and in order to optimize a system, you need to exchange the information between the parts of the system. Now, let's have a view on what are the actual threats against the industrial system. Well, in the recent past, okay, 2 years ago, the last statistics we have are coming from 2019. And those statistics are coming from a very interesting document. You can Google it, you can look on the internet. BSI is the German federal cybersecurity agency, and they published this statistic in a very interesting document, which is called the Top 10 Threats and Countermeasure to be deployed in 2019. Well, I will not comment out everything, but just to give you an idea, because, well, cybersecurity and cyber attacks may look somehow magical. There is some secret part, some obscure part, let's say, of this activity. Actually, things is mostly decoy and deception. Okay, so the main infiltration way in of the viruses and the malware and the attack, finally, if you enter in industrial system, is the external hardware. The USB key is still the best way to attack an organization. So the typical cyber attack against critical infrastructure, against a corporation, is to drop some USB disk with viruses in the corporation parking. So there are still a lot of people, even today, when they find an USB key on the ground, what they will do, they will connect it to a computer to see who belongs the USB key. Okay, so it's already too late. Once you have connected an unknown USB key to a corporate computer, so potentially you have infected all the organization. Okay, the second best way is phishing, and no, excuse me, social engineering and phishing is the fifth one. The second one is malware bring by people from internet, because, well, the problem is that today we are all connected. So most of the people will use, unfortunately, professional computer for personal use, and maybe they will use professional computer for personal use at work. It happens quite often, even very often. So they might bring some malware, some viruses from internet during work hours. It happens, and this is the second best way to attack a corporation. Well, human error and sabotage, okay, will not comment out because, well, it may happen. What is interesting is social engineering and phishing. I don't know if it's happened to you to get phishing and spam by mail, but I mean, to me and Jean-Marc, let's say, it's happened very often. My professional mail address is more than 20 years old, so most probably there are my professional mail address is on a lot of mail listing that is exchanged between hackers. So I'm regularly receiving mail informed me that I'm the happy winner of $20 million, and I just have to provide my bank information to some unknown person and something like that. So yeah, so it is a classical deception tactics, and well, it works pretty well. Actually, it may look stupid, but it works pretty well. So it is, however, the fifth best idea to use to attack a corporation. Okay, just send some phishing mail and use social engineering against the employee of the corporation. Well, control components connected to internet. Control components connected to internet, that means that there are people connecting a PLC to internet. Well, exposing an industrial device on internet, it's extremely dangerous. So most of the manufacturer themselves, most of the governmental agency, they are scanning periodically internet, and there are even some specialized websites which are looking, are searching for control devices directly connected to the internet. Why? Because as you have seen, there is no control access on a PLC. If you are exposing a PLC on internet, anybody, anywhere in the world can connect to the PLC and can directly act on our production system. Well, remote access to computer. Well, as we have more and more computers in industrial system, well, you have a problem for the maintenance and the administration. Already patching the operating system, it's a problem because you need someone to deploy patches to do the update of the antivirus of the user, the software on all the computers. And this is a very expensive operation. So typically on an industrial site, the system administrator won't go physically to stay in front of the computer and do the maintenance operation. They will remotely connect to the computers. Well, remotely connecting, it looks to be a very good idea because you are saving a lot of money, but you have to protect the remote connection. And unfortunately, there are a lot of people which are using generical password or no password at all, or maybe you have a password but which is written on a wall, on a post-it, and there are maybe hundreds of people having access to the password to remotely connect to a SCADA system. And it happens very often. It happened in the United States 2 months ago that someone connected to a water treatment system remotely, and it attempted to insert some chemical product, to add some product usually employed for the purification of the water, and the person has attempted to exchange the quantity to pour 1,000 times more than the maximal limit of the purification product, which will be very dangerous. And well, it's just happened that a local operator has noticed that there was a mouse moving by itself on a control screen, and he understood that someone has remotely connected to the SCADA computer, and it was doing some manipulation on the water system. Right? It happens, and yes, it happens a lot because people don't protect remote access. Well, the last one, but maybe the most interesting one, is the use of compromised smartphone in production environment. So, well, there are a lot of people using personal smartphone for industrial and professional operation. And let's say on some of the modern control devices, you may configure the device using a smartphone, using the near frontier contact protocol, or whatever the Bluetooth protocol, or whatever other protocol on contactless protocol available on a smartphone. And well, if you have if your smartphone is compromised, also will be the industrial device you are configuring with your smartphone. Well, once inside, the secondary attack will be usually a privilege escalation. So, well, the main problem for the attacker is to get inside the control system, because once into the control system, well, most of the devices are not protected. So it is very easy to gain access, full access to the operation of an industrial device. It is quite simple to get access to other systems interconnected, and you can fully manipulate the information on a real-time control network while the information is not protected and the communication is not encrypted. Well, if you are looking at the recent events, and they happened last year and even in the beginning of 2021. Well, there are a lot of attacks which are called the big game hunting. Well, what is the big game hunting? So this is an organized attack against a corporation. It's called a big game hunting because it is tailored. So it is targeted to a given corporation, and they are usually ransomware attack. A ransomware attack, so it will encrypt the data of the corporation, and then the hacker will ask for a ransom to provide the key to give the data back. So the first one in the recent past, it was Norsk Hydro. Southwire is an American corporation, one of the American leader of the wiring market. Altran, they are working in aeronautical industry. There were some hospitals because hospitals are very sensitive. CH2 Rouen, it's a hospital in France. They were attacked by a ransomware, and well, you suspect that they paid the ransom finally. I mean, there is no ethics in attacks, so they won't spare a hospital because it's a health institution or because they are healing people. No, they are able to attack, they are capable to attack a hospital, they will attack it. And well, hospital, as they have they are very sensitive to the disruption of operation, they will be attempted to pay the ransom, and that's why they are a primary target for the hackers. Bouygues Construction, so Bouygues is one of the main corporation in the construction field in France and in Europe also, and they were attacked twice, once in 2019 and once in 2020, and we suspect that they paid the first time, that's why they were attacked time. And it was noticed by the governmental, French governmental information security agency that 60% of those ransomware attack were using the Windows remote connection protocol, what is called the remote desktop protocol in Windows. So that's the best way for ransomware to propagate, to spread inside an organization. And even there is a concept, a new concept in hacking and in piracy, which is called the ransomware as a service. And that's the best business in cybercrime. So ransomware as a service, it's a full attack chain. So it will include the people developing the viruses, the people distributing the viruses via phishing, via fake mails and whatever. The people extracting the data, because they will extract some data in order to provide a proof to the company that they are the source of the attack. The people involved with the money laundering, when the companies will pay the data. There are even client relation, let's see, some client relations, so people are specializing in contacting the victim and negotiating the ransom with the victim. And well, that's why it's called a ransomware as a service, because you have a full service chain for the cyber crime which is deployed today. Okay, and well, everything comes from, you can consult this document. ANSSI is the French national agency for the security of the information system, and they are publishing reports periodically about the actuality of the state of the cybercrime. And this one comes from the document published in last year, probably in July or December. Okay, what else beyond ransomware attack? Because ransomware attack are quite generic. They are not specially targeted to the industrial processes. Well, there are something called process-oriented attack. Well, process-oriented attack means that you will manipulate the communication protocols used in SCADA, used in PLC communication, in order to send some bad controls, some malicious controls to the system and to damage the physical process. Okay, it may be a false data injection. So you'll fake the data coming from the sensor, and you'll provide to the controller with a false image of the process status. It will consist, of course, of exploitation of one of the countless vulnerabilities of the OT technologies, or maybe of the IT technologies. And typically that will lead to something which is called loss of view. That means that the control room will have a false image of the process status. They will believe that everything is okay, and actually nothing is okay. Everything is wrong. A loss of control. So typically the control room will try to retrieve a good state of the process, to bring the process to a normal state, but well, the malware, the virus is inside, or the attacker would impeach the control of the system, which is called the loss of control. And finally, eventually, that will finish with a physical process damage. Well, there was a proof of concept, which is actually quite old. It is called something Aurora vulnerability. Well, that was a proof of concept, a very early proof of concept. They getting back in 2011 or maybe 2012, made by the Idaho National Laboratory. So the Idaho National Laboratory is the biggest industrial cybersecurity lab in the world. So it is a real electrical power system, but dedicated to cybersecurity. So the United States, they have built a special distribution system and generation and full-scale electrical system, but which is not used to supply power to enterprises or to final user. It is used for cybersecurity studies. And well, they do this proof of concept, which is called Aurora vulnerability, and they set up a cyber attack that sent wrong controls, sent some wrong set points to a generator, and it provokes some current spikes, some very short raise of the current in the secondary of a circuit of a generator that finally set the generator on fire. So it is you can look on internet. There is a video very impressive about showing the generator burning due to the cyber attack. And of course, there was the final proof of concept, which was the Stuxnet attack, the American blackout in 2003, and the Black Energy. And we'll talk about those important events, not about Aurora vulnerability, because that was a demonstration of what a cyber attack can do. We'll talk about the real cyber incident. And I will start with the United States Eastern Coast blackout in 2003. Well, actually, maybe you never hear about that as a cyber attack, because it wasn't a cyber attack. It was what is called a cyber incident. So it wasn't set up on purpose. It was an accident. But the problem is that some people have noticed, it was 7 years before Stuxnet, so 7 years before we start talking about the cybersecurity of industrial system. But somehow some people have noticed that you can obtain the same effect as this cyber incident by a cyber attack. And okay, let's say what the cyber incident was. I'll provide a short and I hope comprehensive description of the incident. Okay, it was in 2003. Okay, for the students, most of you, I suppose you are too young to remember 2003. It was a very hot year. It was a very hot year, and the incident occurred in August. In August, in United States, it was a very, very hot time, and this is important because they are using a lot of air conditioning. So air conditioning means you have a lot of electrical consumption. So it was a spike of electrical consumption in the United States due to the fact that the time was extremely hot. Well, and everything started with a false sensor data injection. Well, actually, it wasn't an attack. It was a maintenance error. it happened that one of the sensor, the current sensor in the electrical network, so you have sensor like in any other process, but they will measure, those sensor will measure the intensity of the current in a distribution network, okay, in a electricity transportation network, put it like that. And one of the sensor was failed, and they sent an operator to do the maintenance, to change the sensor. He changed the sensor, and now what happens is that in electrical networks, there are two normalized, two standard category of sensor. One sensor sending one category of sensor with an output between 0 and 1 ampere, and another one with an output between 0 and 5 ampere. Both are supported by all the PLC in the world, by all the protection relay used in the electrical distribution in the world. You have just to configure the relay and to say your sensor is a sensor providing an output between 0 and 1 ampere or 0 to 5 ampere. Well, the operator exchange one sensor with an output between 0.1 to a sensor with an output between 0.5. That means that for the same input, the indication, the output of the sensor was 5 times lower. He reconfigured the device, but he forget to reset the device, to restart the device. So actually the PLC didn't take into account the modification. For the PLC, the data was still provided by the other category of the sensor. So what happened, of course, is that the PLC gets wrong data from the sensor, has wrongly interpreted the data for the sensor. And finally, the control room built a false image of the state of the electrical network. And this is very dangerous. So, the image built by the control room is called the estimator. The estimator, well, it's an image of the electrical network. Well, to understand what it is and why it is important, I give you here an image of an electrical network. It is not the eastern coast of the United States, it's the western coast of the United States. But anyway, what I want to point is what an electrical network look like. Well, if you see this image, you can clearly see the electrical lines, but it doesn't tell you too much unless you are a very, very pointly specialist and you very, very well know what each line means. It is very difficult to interpret. So this image is very nice. The geographical image is very nice, but it's completely useless for the control room. What the control room will use instead is something like that. So this is the estimator of the state of the electrical network. And well, typically what you have in the upper part of this image, you have the generators. You see generator 25, 23, 22, and so on. And at the bottom, you have the name of the consumer. Okay, you have the final user, excuse me. And well, the white lines are the transportation lines, and the generator and consumer will be connected to one line or to another one using the electrical switches. The electrical switches are the red squares you see in this panel. And well, the game they are playing at, so what is the job of the control room is to try to balance the loads, to balance the electricity transported on one line and or another line, such that generator won't be overloaded and all the user will be supplied with electricity. So that's the job of the control room. Well, it goes very well if your image about the state of the electrical network is correct. But if you have a wrong sensor data, your image will be false. Okay, so the image was false. Well, now here you have a real image of a control room. It's come from the National Electrical Network in Luxembourg. I don't know if you know what Luxembourg is. It's a very, very, very small country in Europe. Actually, maybe it's a little bit more than a town. Okay, so I don't know, maybe they are 200,000 people. So they have a very small electrical network, and yes, you can see it like that. Okay, so we go back to this incident in the United States. So they have a false data injection into the state estimator of the electrical network. And what happened? Because the consumption, the electrical consumption was very high, is that one generator was overloaded and it was stopped. Well, that may happen. I mean, this is a current incident. It's an electrical incident. It happens that if you have a very, very high electrical consumption, to overload the generator, and then we'll stop the generator and you'll bring the electricity from somewhere else, okay? But a transport line was overloaded because this generator stopped, and they didn't see it. They didn't see it because of the false state estimator image. Now, if the transportation line is overloaded, what is going to happen? Well, by the electricity law, the current will increase, then the heat produced, the dissipated heat will increase, and if the conductor, if the line is heating, what is going to have? There will be a dilatation, and the line will approach to the ground. And it will approach to the ground. It won't approach directly to the ground, but it will approach maybe to a nearby tree. And at this point, well, the incident encountered the first vulnerability of the system, which was a wrongly trimmed tree. So there is a norm in electrical network that will tell you at which height you have to trim a tree, depending of the distance to the nearest electrical line. So here you have an image of the French specification that will tell you that, let's say, if you have a higher voltage line, if the tree is closer than 3 meters, you don't have to, it doesn't have to be upper than 3 meters. If it is a longer distance, so more than 5 meters from the electrical line, it can be higher. Okay, so all the electricity operator, they have specialized teams that will trim the trees which are closer to the electrical line. And there was the first vulnerability of the system. They had wrongly planted tree, wrongly trimmed tree. It was too high, and the overloaded electrical line discharged to the tree. Okay. Funny, they lost the high voltage transportation line, and there was a second vulnerability of the system. There was a bug in the alarm system. The bug in an alarm system that blocked the alarm system. Well, it was something called a race condition. If you know about concurrent programming, a race condition means that you are changing the order of the events. Okay, so you have a problem in rebuild the order of the events coming to the system, and the bug was very, very important, such that it blocked the alarm system. So not only the control room was blind, they see a wrong image of the system, but also they didn't get the alarm. So it looks like a worse cyber attack scenario. And the network start falling. The network start falling. That means that more and more lines were overloaded. And when a line is overloaded, the local protection will disconnect the line. So they start losing one after the other, the transportation line in the electrical network. And it finished very bad. It finished with over $6 billion lost, and even 100 casualties, not direct casualties, but when they black out a very large part of the United States, there was a panic movement. There was a lot of people that tried to like with scandal, that set up fire in the houses. People trying to leave the cities, and they die in car accident. So there were over 100 casualties, and everything started with a badly maintenance operation. Excuse me, I see that there are some messages in the chat. I try to get. Okay, I guess the message is not for me. Okay, I'm going back to the presentation. So to sum up the conclusion of this event, the starting event was an accidental force sensor data injection. It exploited cyber and physical vulnerabilities of the system. The physical vulnerability was the wrongly pruned tree, and the cyber vulnerability was the race condition that blocked the alarm system. It involved a loss of view. So the supervisory had a wrong view of the system, and they lost the control. They were unable to control the system. It physically damages the plant. It physically damaged the electrical network because they had to black out a lot of people. There were some human casualties, even collateral. And actually, if you are looking at the communication, there were no syntax or semantics violation, meaning that there was no computer magic involved. So everything was just related to a wrong manipulation of the data, but somehow in a legal way. Okay, so that was somehow the prequel of the cybersecurity activity, and everything started with Stuxnet in 2010. Now, Stuxnet, again, probably for students, it's a very old event. Well, compared to the history of the cybersecurity, it's still a recent event. Now, Stuxnet was really a cyber attack. If you don't know the story, it was a cyber attack. Now we know because it was recognized that it was a government set up attack, and it was set up by Israel and the United States against Iran. And the idea was to stop the Iran nuclear program because while they were suspected that they are not developing only civil nuclear facilities, but also military nuclear facilities. And while it was longly prepared by the Israeli cyber specialists with the help of the United States and the CIA, and they finally set up this virus that eventually has damaged the nuclear facilities of one of the Iran nuclear plants. Okay, now I want to talk about how the virus was introduced to the site. So people think there was some social engineering. They they don't send, they approach a serviceman, and they were able to provide a serviceman with an infected USB key, which was connected to one of the computer of the Iranian site. Well, actually, we don't know, but what we know is what the virus had do once inside. And what it do once inside, and this is the important part and the meaningful part of the story, is that it start searching for a special type of computer, actually for a computer that was used to program PLCs. Well, step 7 is the Siemens PLC programming environment. So they knew, the attacker knew that on the site, the industrial site was equipped with Siemens PLC. So they targeted specially a special and a very precise model of Siemens PLC. So the virus look for a Siemens PLC programming environment on a computer, and once they find this computer, such a computer, maybe several computers with this programming environment installed, it exchanged the communication driver. Actually, it charged the communication driver with another virus, which was the virus targeting the PLC. And they look, so the virus was looking for a special model of PLC, which is called S7300, which is one of the oldest and very well-known PLC produced by Siemens. You can look on internet for this model. It is still available in the Siemens software. Okay, they don't only look for this PLC, but they also look for a local loop. So we go to the local loop. So the PLC was used to send the set pointer to a local loop controller. And the local loop controller was a speed driver, a speed controller connected to something called Profibus. Profibus is a field network, is the field device network used by Siemens PLC. So it's the real-time network from Siemens. Once the virus found the speed controller connected to Profibus, it starts to record the sensor value of a normal behavior. So it was a very, very complex and very, sophisticated treat. Once he set up a record, he started playing this record to the SCADA, to the control room, and he started sending malicious controls, malicious setting points to the drive controller, and the drive controller has wrongly set the speed of the motors, and finally that bring the system to an early damage. So it damaged the plant, the physical plant, which was a centrifugal accelerator for the uranium enrichment. So that it was a site producing nuclear supplies for the Iranian nuclear program. So the story ended with a physical system damage that durably stopped the nuclear development in Iran. It stopped it for 4 or 5 years. It involved a very deep knowledge and a very detailed recognition of the site because it was targeted to a very specific PLC model with a very specific communication card model and a very specific local loop controller. It brings to a loss of view, so that the control room has never seen a problem on the physical plant. There was no protocol violation, so there was no magic in the communication. The magic was in the virus, and they lost the control of the plant because finally the plant had a wrong behavior. So that was the starting point. So it was very fast, very often spread and known by the media the occurrence of this event because Iran has communicated a lot around of this incident as they have a conflict with Israel, they have a conflict with United States, and well, practically all the cybersecurity activity in the world in the field of industrial control systems started after this event. So before 2010, there was nothing, and after 2010, practically all the government, all the manufacturers and operators start activating cybersecurity activity. Well, the last one, the last event I want to mention is one of the attack against the Ukrainian power grid, the one called Industroyer. Now, why it is interesting? Because, well, in power distribution, you know what are the program running in the PLC. Why you know what are the program? Because practically all the power system are the same from the control point of view. So you are implementing the same protection function, and the protection function are normalized, are described by standards, and all the constructor will implement same protection function. So what is inside the PLC? It is easy to know. You don't have to do a detailed recognition on the site. You don't have to know the exact model of the PLC because, moreover, in power distribution, they have a special class of communication protocols, and all the manufacturers will comply with the same communication protocols. But what is unknown is the state of the process. The state of the process meaning the distribution of the loads between the electrical line and the state of the power switches. And well, on the other hand, the problem is that the distribution system is a very complex system. So you have an image of what a small distribution system can be, and all the circles are generators, all the double circle are substation, are power transformers, the horizontal line are the transport line. So it might be, it will be very fast, very, it will turn very complex once you are considering a real distribution system. So the main problem in attacking an electrical network is to know exactly what's the state of the process. You know what are the devices, the controlling devices. You know what is in the controlling devices, what are the control function, but you don't know what's the state of the system. And well, actually, that was the particularity of this attack. So this attack, the malware has attacked, has looked, has searched for an industrial database system, which is an OPC server. So, okay, to make it simple, let's say it's like an SQL server, but it's oriented to industrial system. Why they look for this one? Because an OPC server, so the database server, will acquire all the data from the physical process, and this server has a knowledge, knows the cartography, knows the topology of the control system. He knows where are the PLC, he knows where are the control rooms, he knows what are the IP addresses of the PLC and what are the IP addresses of the control rooms. Okay, so they look for an database server in order to get access to the cartography, to the architecture of the system. And once they get that, they look for a no model and no vulnerability on a PLC device. And actually, they attacked the human machine interface. So they attacked the control room. Let's say, make it simple. And the virus move on the HMI and open some backdoors. And at this point, there were some manual operation, meaning that some remote electrical engineering take control on the control room, and they do the malicious operation on the control room. They supersede the local operators. They start to open switch and to close switch and to bring the electrical network in a bad state. And yeah, finally, so they send the bad controls to the PLC, to the controlling devices, and they black out a part of the system. So they particularity of this attack is that they did a recognition via an OPC server. Then they didn't use magic from the point of view of communication, so they use only legal controls, but the wrong controls that bring so that occur in a loss of view. The controls, the real control system see nothing. They even been blackout themselves, or they black out two control rooms. So they lost control. Okay, because the control was to the hackers, and finally has physically damaged the system because they black out part of the country. Okay, so that's the last classical event I want to talk about. And okay, let's move now to some more formal cybersecurity related definition. Now, if you want to secure a system, okay, the first question is, what do you mean by securing a system? What will define the security of a system? Well, for the control system, we'll talk about the classical security objectives, but for the control system, the most important is the availability. So you want that your system, the control function, will still be available even if your system is under attack. So that's why, well, on the contrary, on a computer system, you cannot just shut down the system if you are under attack, because shutting down, let's say, a nuclear plant, it's a very complex action, and you cannot do it just like that. So the availability is the most important feature that you have to ensure in an industrial control system. Then, secondly, if you will secure your system, let's say you start closing doors. So you stop some accesses to your system. You maybe will keep some, okay, you impeach some legal operation. So there is another feature of the cybersecurity of an industrial system, which is called a non-repudiation. Non-repudiation means your security system shall not impeach legal operation. So you don't have, you shall not have false positive, okay? A legal operation shall never be considered as an attack and be blocked. Okay, let's say, for instance, you are blocking an emergency stop, okay? An emergency stop is not something that occurs very often in an industrial system. But if your system will see a control, which is an emergency stop that he never seen before, he may consider it as an attack that should not occur. Real-time properties, so that the timely response to control is extremely important in industrial system, and you have to ensure the real-time performance of the system. So those are the most important feature, let's say, of a security system deployed in an industrial control system. Also, the reaction time is very short, because consider the attack against the power system. You have an attacker that starts shutting down your electrical network. You have to react very fast. So if you are waiting, let's say 20 minutes, it will be already be too late, because you have half of the country blackout due to the attacker action. So the attack will always target the physical process. That's why, once again, the main asset to be protected is the physical process. So we are concerned with the physical process security. Well, from the point of view, let's say, of the different type and kind of processes. So, but, well, I won't insist too much, because Jean-Marc has talked about this. So we have two kind of processes. The one which are driven by events, which are the sequential system, and they are also known as manufacturing system, and most of them are controlled by PLC, and also which are driven by a time dynamics, and those are what the control system in general is concerned with, and those are called processes. Well, typically there are feedback systems, so you have a regulator, a PID, or whatever that will ensure the control of a process variable. Well, somewhere between the two, you have the electrical transport and distribution, which are known as hybrid system, because, well, you have a continuous dynamics, a time-based dynamics of the system between two events. And one event could be you are switching on or switching off one of the circuit breakers, so you are changing the topology of the system. Okay, so, well, those characteristics are important to the cybersecurity deployment, because you are not applying the same technique, and you are not the same type of problem for for a regulation, let's say a continuous time system, or a manufacturing system, or an event-based system. Okay. Now, if you want to deploy cybersecurity on your system, first of all, you have to understand the concept of threat, vulnerability, and attack. So this is part of the basic approach to the cybersecurity. Then, well, actually, the core of the cybersecurity is the risk evaluation and risk mitigation, and all the technique Jean-Marc was talking about will apply to the cybersecurity. So the risk evaluation and risk treatment are not different in safety and in cybersecurity. And the same international standard, the 31000, is applying for cybersecurity. You have to understand SCADA and industrial networks. You need to understand security objectives and control, and we'll talk in the following about the security objective. And this is all at a basic level. Now, if you want to go into an advanced level, you have to be able to use the security controls, like deploying a firewall, like setting up a VPN access, or setting up a secure gateway. You need to understand, therefore, the data network and security control to be able to compare different industrial security solution. What firewall will provide us an advantage, what a deep packet inspection means, and so on. And for the experts in cybersecurity, you need to be able to evaluate the security of a device or a system and to propose a security plan. Okay, so my presentation, let's say, we'll start somewhere at the beginning of the basic understanding of cybersecurity. So a full presentation and a full class on cybersecurity will be something going to the expert. Let's say we have to count a week of master class and labs. Okay, now there is one international standard speaking about the cybersecurity guidelines, and we'll talk about some preliminaries of cybersecurity. And in some 20 minutes left, I will try to give you a short view of how to simply evaluate the security level of a system. So the first question you have to ask is what you have to secure. Okay, so you need to define the size of the organization. Are you concerned only with the physical process? We are concerned with the computer also, with the network, the people, the application, the data, or whatever. What do you mean by secure? Again, you have to define a policy. So what do you mean by secure is defined by the security policy. And there is no absolute answer to what is a secure system. It depends. It depends on the system. It depends on the security policy. It depends on the activity of the company. It depends on the risk evaluation and on the threat model. And because we are speaking about the threat model, you have to defend your organization against which kind of threat, because it is not such a concept as an absolute security. Okay, let's say most probably nobody will be able to defend an industrial system against such a sophisticated attack like Stuxnet. If you are attacked by a foreign government will be able to spend years and spend millions or billions of euros or dollars to set up a very sophisticated attack. And if you are a particular company, it is quite impossible to defend against this. Okay. You have, however, checked the vulnerabilities. You have to consider which are the threat available resources. So you are talking about an individual. You are talking about a disgruntled employee, which is very dangerous because he has a lot of access, but he has a limited financial resources. You are talking about a criminal organization, like the people perpetrating the ransomware attack against your companies, or you have to defend against an enemy state. Okay, what you have to do, finally, so you are defined against which type of threat you want to protect your system, and what you have to do. What's the choice of control and what are the available control and how to do. Actually, the how to do is very important, because let's say it clear up. Most of the people will tell you have to set up a firewall. Yes, but you are setting up a firewall. That's the simple step. You have to maintain the firewall, and this is far more difficult. And maintaining the security system, it is called the security management. And this is a full process and a long process and a very complex and expensive process. It's not a one shot. I'm deploying security controls and now I will be protected until the end of time. This is not true. Okay, now the general cybersecurity lines, guidelines are specified by a ISO standard, which is the 27032. And this is concerned with the information security in general and the physical processes and what is called critical infrastructure processes in particular. So critical information infrastructure processes, which is including industrial control system and electrical networks, is part, it will overlap with information security standards. If you want to protect your critical information infrastructure, you need to deploy network security, because today all the industrial systems are network connected and all the operation are based on the data exchange, and you have to ensure the internet security. Most of the threat will come from internet, either by malicious scan, by tentative of external connection, vulnerability exploitation, and so on. Well, at the end of the line, you have to ensure the application security. The application security may be the control of your electrical system or the supervision of the industrial plant, or maybe it will be an optimization operation on cloud and big data application. And everything is part of the cybersecurity deployment. So critical information infrastructure, which concerns the industrial control system, needs network security, needs internet security, needs application security, and in general, we rely on the information security. So this is the general guideline. Now, in order to understand the objective and how to evaluate the security, let's have a very short look inside the most important information security standard, which is ISO 27000. Well, there are probably 40 or 50 chapters in ISO 27000, so we cannot cover everything. I will just speak about some of the features presented and the requirement presented in the introduction of the standard. So the information of securities traditionally will rely on three main security objectives, which are the confidentiality of the data, the integrity of the data, and the availability of the data. And these three objectives are known as the CIA triad. CIA, like confidentiality, integrity, availability. Now, for the industrial control system, we have seen that the availability is the most important. Then the integrity is also quite as important as the availability. And, well, really confidentiality is the less important for the industrial control system. Okay. Is the less important because your main objective is to ensure the security, the physical security of the physical plant. Now, well, this is the, let's say, the basic evaluation criteria, CIA. But in addition, of course, CIA will not cover everything. So there are some other properties which may be considered, like authenticity, accountability, non-repudiation, so you don't have to refuse legal operation, which is extremely important for industrial system, and reliability. Okay, resilience is also very important for industrial control system. Resilience means that you are able to keep a minimal quality of service level even if you are under attack. So that's the definition of the resilience, not only in cybersecurity, but in general. Let's say for the fault tolerance system, we talk about resilience as the capability to keep a minimal level of the system function, even in presence of a fault. The CIA triad. Okay, so confidentiality. That means that information will be available only to people, authorized people or entities or processes or computer or network or whatever, which are authorized to have access. Integrity means that you are able to guarantee the accuracy and genuineness of the information, the completeness of the information. So you can guarantee that nobody has tampered with your information. We are guarding the data against accidental or malicious intentional modification. The availability, so the information, the data or the devices are accessible and available to the authorized people and entities. And of course, the availability has to be reliable and timely. So we suppress the real-time aspect. So quite often there is a fourth characteristic that is added to the CIA, which is the proof. Okay, the proof is the capacity to prove who was made a modification or who interact with the system. Authenticity, that means an entity interacting with your system is able to prove his identity, to prove that is what is claimed to be, and no repudiation, so you are not refusing, you are not blocking a legitimate action. Well, reliability, so you are, the behavior and the results of the process are consistent. Now, a very good information, it's when I'm designing, let's say, we'll consider only CIA triad, when I'm designing that my system is secure. Well, typically the objective of security will be evaluate on a qualitative scale. So quite classically, we're using a 4-level scale. We say that we have an availability, let's say, which is low, average, high, or very high. Well, you can add a 5th level if you want, but well, most of the people will use only 4 levels, and traditionally we are using 4 levels. Now, suppose you are evaluating the CIA objectives of an asset, a web server or whatever, a mail server. And let's say you see that the availability is very high, the integrity is average, you are evaluating, okay? You are just making the state, you are evaluating the state of the asset before deploying whatever controls. The confidentiality is maybe very high and the proof level is very low, okay? Now, if you're looking at that, what you're gonna decide? Is your asset secure enough? Is not secure enough? It is unsecure? It is very secure? Well, difficult to say. You have 2 objectives scoring very high, 1 scoring average, so it is however low, and 1 low. Well, there is no correct answer. Just with this information, it is impossible to say, I have a good level of security. Depends what your asset is and what are the objectives you are needing, okay? It is not possible at this moment, just only with this information to decide, to conclude if the security level is good enough or not. So it depends about the asset type. So now assume the example of a very, very simple web server. Let's say the web server of your university, maybe a simplest one, a web server having only static web page. So you have only pure HTML code on your web server. Okay, the simplest case. Now, what you're gonna need? So you have a web server. It's a public web server, and it will advertise the activity of your enterprise, the activity of your university. So you want this web server to have a very high availability, clearly. But the confidentiality, you don't care. You don't care because it's public. All the information is public. You want to make it available to the whole world. So you don't need confidentiality. The confidentiality could be low, could be even 0. No confidentiality. But as is an advertising server, you want a very high integrity. You don't want that someone will tamper with the information on your website. Let's say change the information or change the schedule of the class of the university or whatever. That will be very embarrassing. So you want a very high integrity of the information. And the proof, you don't care. You don't care because it is a public server. You don't want to know who's consulting the web page and who read what web page. You really don't care. So you may have a very well secure asset with only 2 objectives scoring very high and 2 others scoring low. But depends what the asset is and what your security policy is. So a reasonable security policy for a public static web server will be don't implement confidentiality. You don't need secure protocol to access the web page. You don't need a proof of the activity, but you need a very high availability and a very high integrity of the information. So that's the idea of the security, and it is the mandatory first step of the cybersecurity deployment, to be able to evaluate what you need. Okay, now let's have a very fast view of the available controls. Well, if you want to know more, there is a public specification coming from NIST. It is called the NIST Special Publication 953. NIST is the North American Institute of Standard and Technologies. So it is the United States main authority for the standardization in the technical field, in communication and technology. And well, the main advantage of NIST is that all the publications are public. You don't have to pay for. If you want to read, let's see, the ISO 27000 standards, this is very, very expensive. So you need several thousand euros for a single people access to the standard. So, well, usually for students, we don't recommend attempting to read the standards because it is unaffordable for students, but we recommend reading the NIST publication, which are public, and the information inside is practically the same as in the, well, okay, it is similar, it's not the same. It is similar to the one in the international standard. Okay, so let's have very fast several examples to understand what is a security control, and you'll see that a security control is something that most probably you know and you are already using. Well, a very well known by everyone security control is the antivirus. So that is the piece of software that will allow you to detect the malware. And if you're deploying an antivirus on your system, that will increase the availability of your system, because a virus, well, will maybe involve a fault of your operating system. It will increase the availability. It will increase the integrity of the system, because well, if you get a ransomware, that may compromise the integrity of the data on your computer. It will also increase the confidentiality of your system, because there are some viruses that will extract information from your computer, but it will not increase the proof of the proof objective of your system. If you are using cryptography, so you are encrypting the communication and you are encrypting maybe the data, and you are encrypting the, let's say, the files on your computer. So that will increase the integrity of the data, because you are the only one able to access the data, or only the people you authorize specifically will be able to access the data. It will obviously increase the confidentiality of the data, and also the proof, because only people entitled and the entities entitled to access the data will have access, but it will not increase the availability of the system. A firewall. So the firewall, it's able to block some network flows. Okay, the firewall will increase the availability, because well, it will block maybe some denial of service attacks, which are a lot of data sent to your system with the intention to block your system functionalities. Which will increase the confidentiality of the data, because there will block also some intruders which are not allowed to enter the system. Which will not increase the integrity of the data, okay? Because if the flow is authorized, the firewall usually will not check the data inside, okay? If you are authorizing, let's say, data flow from my computer, and I'm sending to you malicious data, the firewall will not block the data, because my information flow is authorized. And it will not increase the proof, because you cannot track back my activity. You just know I did something, I sent some data to your system, but you don't, you are unable to track what which action I made into your system. The access control. So you are allowing only people on an authentication basis. So this will increase everything without accepting the availability, but it will increase the integrity, confidentiality, and proof, because you know who's doing what on your system. The physical security. Once again, cybersecurity starts with physical security. The physical security, well, will increase availability, because there will be a lot of harmful people that we cannot get access. The integrity, because you know that only authorized people get inside, and the confidentiality, but will not increase the proof. And we'll finish to last one. Audit and accountability. So you are checking the security feature of your system and you are logging the events. Well, that will increase everything, because if you are auditing your system, you may detect the vulnerabilities of your system, and detecting the vulnerabilities of the system will allow you to correct some vulnerabilities, so that will improve all the characteristics of the security. Awareness and training. Awareness and training, so you have to aware all the people, all the users of the information system about the risk in related to the network and the internet, and training, so you are improving the skill of the user, and this will also improve all the characteristics of the system. Okay, so this will end my presentation, I guess. So if I'm not wrong, I'm afraid that I was even longer than suppose. Excuse me, I got lost of the tracking of time. So it was until 4 o'clock.
It's okay. It's okay.
It's okay. Okay, I'm sorry. I'm really sorry. I don't know why. I was sure it is until 4, half past 4.
It could happen. No problem. So I think almost all people are here. It means that your presentation was very interesting, and they receive it perfectly. So thank you again, Professor Stéphane.
Okay. So sorry for the extra 30 minutes.
It's
okay.
Okay.
So yeah.
It's okay. Okay. So I want to thank again Jean-Marc Thirier and Professor Stéphane Mocanu for this nice presentation. And as I said, normally we will make available the slides. So Stéphane, if you can send me the PDF, it will be good. And
well, I will put the PDF on the Moodle.
Okay, so if you are able to...
So there will be far more information, because actually what I have in the presentation, the full presentation, is my whole introduction class to cybersecurity. Okay. So it will be far more than in the
great
presentation.
Great. Okay, and the video will be accessible to in a few time. And another point is about the forum. Please don't forget to ask questions using the forum. As I said, we have done several courses to make you ready to do it. So you can go to how to use Moodle Factori 4.0, and you will see some video like tutorial to help you how to ask a question in the forum. And we have another courses named video offline of the courses, because we are recording every seminar done by our teachers, and you will be able to see again the presentation. That's all for now. Again, thanks to all the audience, students and teachers from MEFALO. And
thank you.
And we'll see you soon for, I think, the last courses. Okay, so bye-bye to all.
Thank you very much. Thank you very much.
Nice evening to all.